Not all the data are the same. Next, we will discuss the different ways to classify our data. A statistical variable is a characteristic that varies from one object to another. For example, age, major, GPA, and the desired grade are not all the same for all the students. Therefore, each one of them is a statistical variable. The values of a variable for one or more people or things yields data. So there's a we're going to discuss two different ways to classify our data. So the first way, we're going to classify data into two groups: qualitative data and quantitative data. The qualitative data consists of names and labels describing the attributes of a population, such as hair color, blood type, ethnic group, the car person drives, or the street that the person lives on. Qualitative data are generally described by words or letters. For instance, hair color might be black or dark brown or blonde, and the blood type could be A, B, or positive or negative Rh factor. Quantitative data consists of numbers that are the result of counting or measuring attributes of a population, such as the amount of money, pulse rate, weight, number of people living in your town, or number of students who take a course. While numbers usually mean quantities in general, not every number represents a quantity. For example, zip codes do not mean quantities, therefore they are qualitative rather than quantitative type. Also, phone numbers, student IDs don't mean quantities. And since they're unique for each subject, they're called identifiers. So again, identifiers are usually represented by numbers, but don't mean quantities, and they're unique for each subject. The qualitative data could be further divided into two categories: the categorical and ordinal data types. So categorical data types have no natural order. For example, colors, college majors. So the categorical data that has two possible values is also called binary, and that's answers such as yes or no or agree disagree. This is binary categorical data. Note that not all categorical data are binary, like we mentioned before, colors. That's categorical but non-binary data. Ordinal data has natural order. Examples: letter grades. We have from best to worst, A, B, C, D, F. Clothing sizes from smallest to larger. Likert scale, uh, basically labeling as services as poor, fair, good, or excellent. Next, quantitative data could be also divided into a discrete and continuous data. So this discrete data is the data where all possible values can be listed, and there are natural gaps between possible values. So for example, shoe sizes, we have 5, 5.5, 6, 6.5. So there are gaps in between sizes and they're occurring at irregular intervals. Age in full years have gaps. Number of cars in a household, weight rounded to, if rounded to a nearest pound. For continuous data, all possible values uh, from continuous interval with no gaps. So for example, if we don't round weight and we write down all of the decimals, that's an example of a continuous data set. Exact time, such as 2.6 seconds. Exact length, 58.27 inches. And um, now with this, with continuous, like we said, with continuous data, any accuracy is possible. So we're only limited by the instruments that we're using to take those measurements. For example, for the length, here we wrote down only 2 decimals, but if we have a really good instrument, we could have 5 decimals, even 10 decimals. So there is no limitation on how exact our values can get, as opposed to discrete data. Here we have a rounded value. Here's an example of different types of data collected from the set of TV shows. So rank is a discrete value. Now the show title is an identifier. And then the network is categorical data, and viewers is number of viewers is continuous data. Okay, so let's summarize. Here we list our data types from the least complex to the most complex. So we have qualitative, quantitative, where qualitative is divided into categorical and ordinal, and quantitative is divided into discrete and continuous. Okay, now let's talk about another way to divide our data. Okay, so again, I want to mention that it is a second way to divide our data. So we're basically starting from the beginning again. So it's called levels of measurements, right? So there is nominal level where the data can not be arranged in any ordering scheme. So we cannot put it in any order. So examples, answers yes or no, undecided, political party affiliation. Next level is ordinal. In ordinal level, the data can be arranged in some order, but differences between data values are either cannot be determined or are meaningless. So for example, grades and ranks. We can put grades in order from best to worst, so vice versa, but we cannot subtract them and get something meaningful out of that. Now the interval data. The data can be arranged in some order for which the difference is between values are meaningful, but there is no natural zero. So for example, temperature, years. Okay, so if we subtract the difference in temperature has a meaning, but the temperature does not have a natural zero because it depends on the scale actually. So if we compare Celsius versus Fahrenheit, they all have different zero values. It's arbitrary. It's not a natural zero. There is only one scale that has a natural zero, but since we don't use it, we actually use different scales. The temperature is an interval um, type of data. Also with years, again, if we talk about years as dates, let's say 2022 versus, 12th century BCE, that uh, mm, years do not have a natural zero. There is no year zero. And again, um, it depends also on the calendar because Chinese use, for example, they use their own calendar, so they have a different um, type of. I don't know if they have year zero, probably not either, but year zero does not exist as far as I know. Correct me if I'm wrong. But if we talk about age and we say that someone is 0 years old, that means that they just started living. That's their year zero. So in this case, when we talk about age, that goes that data value comes from ratio level of measurement. And the ratio level is the data can be arranged in some order for which not only the differences between data values are meaningful, but also there is a natural zero. So that's the difference between the interval and the ratio level of measurement. And examples of ratio level would be distances where zero distance means no distance naturally. It's a natural zero. Prices, when something costs zero, that means it doesn't cost anything, so that's a natural zero. And time as a measurement. So we can match the two classifications in this following table. So this is our first type of a classification, and this is our second type. Okay, the first classification addresses what the data look like, and the second classification addresses what can be done with data mathematically. Also, keep in mind that the framework of distinguishing levels of measurements, so the second classification, was originated in psychology and is widely criticized by scholars in other disciplines. So this is it for types of data. If you have any questions, please let me know in the class. My cat came and ruined it, everything. Okay, guys, I'll see you later.